What is an intrinsic and extrinsic semiconductor? An intrinsic semiconductor is a poor semiconductor material like silicon or germanium without any impurities. In this type, the number of electrons is equal to the number of holes and the conduction electrons due to thermally generated charge carriers. An extrinsic semiconductor is formed by adding small amounts of impurities to a poor semiconductor to increase its conductivity. If pentavalent impurity is added, it becomes an n-type semiconductor with electrons as majority carriers. If trivalent impurity is added, it becomes a p-type semiconductor with holes as majority carriers. Explain the formation of p-n junction. A p-n junction is formed when p-type and n-type semiconductor materials are joined together. When they are connected, electrons from n side diffuse into p side and combine with holes. Similarly, holes from p side move to the n side. This movement creates a depletion region near the junction where no free charge carriers exist. An electric field is developed across this region which opposes further diffusion. This region acts as a barrier and controls the flow of current in the diode. What is superconductivity? Superconductivity is a phenomenon in which certain materials show zero electrical resistance when cooled below a specific temperature called the critical temperature. In this state, electric current can flow without any energy loss. Superconductors also expel magnetic fields from their interior, a phenomenon known as Meissner effect. Superconductivity has an important application in MRI machines, magnetic levitation trains, and particle accelerators. What is population inversion in lasers? Population inversion is a condition in which the number of atoms in an excited energy state is greater than the number of atoms in the ground state. Normally, more atoms stay in lower energy state. In lasers, external energy is supplied through a process called pumping to achieve population inversion. This condition is necessary for stimulated emission, which produces coherent and intense laser light. What is polarization in dielectrics? Polarization in dielectrics refers to the alignment of electric dipoles inside an insulating material. When it is placed in an electric field, the positive and negative charges inside the atom shift slightly in opposite directions. This creates dipole moments within the material. Polarization reduces the effective electric field inside the dielectric and increases the capacitance of capacitors using dielectric materials. Explain the working of a rectifier. Rectifier is a device used to convert alternating current AC into direct current DC. In a half wave rectifier, only one half of the AC cycle is allowed to pass through a diode. In full wave rectifier, both halves of the AC signal are converted into DC using 2 or 4 diodes. Full wave rectifiers are more efficient and provide smoother output compared to half wave rectifiers. Rectifiers are used in power supplies of electronic devices. Explain the working of Zener diode. A Zener diode is a heavily doped PN junction diode designed to operate in the reverse breakdown region. When reverse voltage reaches the Zener voltage, breakdown occurs either due to Zener effect at low voltage or avalanche effect at high voltage. In this region, current increases sharply but voltage remains almost constant. Because of this property, the Zener diode is mainly used as a voltage regulator in power supply circuits to maintain constant output voltage. Explain avalanche and Zener breakdown. Breakdown in a diode occurs in reverse bias when voltage exceeds a certain limit. In Zener breakdown, which occurs in heavily doped diodes at low voltage. Strong electric field pulls electrons from their bonds. In avalanche breakdown, which occurs in lightly doped diodes at high voltage. Charge carriers gain high kinetic energy and create more carriers by collision. Both processes cause a sudden increase in reverse current. Explain the VI characteristics of PN junction diode. The VI characteristics show the relationship between voltage and current in a diode. In forward bias, current increases slowly at first and then rapidly after the cutting voltage 0.7 volt for silicon, 0.3 volt for germanium. In reverse bias, only a small leakage current flows until breakdown voltage is reached. After breakdown, current increases sharply. Thus, the diode conducts mainly in one direction. Explain the working of a solar cell. A solar cell is a PN junction device that converts light energy into electrical energy. When sunlight falls on the junction, photons create electron hole pairs. The built in electric field of the depletion region separates these charge carriers, generating current. The VI characteristics of a solar cell show power generation in the fourth quadrant. Solar cells are used in solar panels for power generation.